In this video we're going to find trig functions for any angle, but this time we're going to talk in radians. We'll solve trig functions exactly for any angles given in radians, and then we'll also approximate trig functions using our calculator, also in radians. Alright, let's look at problems like this. Find the exact value of sine of 3 pi over 4, tangent of negative pi over 2, and cosine of 43 pi over 6. The steps we're going to follow are exactly like the ones we followed when we had our angles given in degrees. We're going to find the reference angle. Again, that's always an acute angle. We'll find the trig function value for that reference angle. And finally, we need to determine the sign, whether the trig function is positive or negative based on the quadrant that the terminal side lands in. Let's take our first example. Find the exact value of sine of 3 pi over 4. Again, we need to first find that reference angle. And we'll do that by going back to our xy axes and our unit circle. But now, instead of 0, 90 degrees, 180 degrees, and 270 degrees, we'll look at this in terms of 0, pi over 2, pi, and 3 pi over 2. Alright, 3 pi over 4. Well, say we don't have our unit circle memorized, then we'll have to look at this and say, alright, it's more than pi over 2, not quite pi. I think an angle of 3 pi over 4 would fall about here in quadrant 2. Our reference angle for that, remember the reference angle is the angle formed by the closest x-axis and that terminal side, and that looks to be a pi over 4. Remember, pi over 4, that's one of our special angles we need to memorize. The sine of pi over 4 is equal to square root of 2 over 2. So now we have the trig function value for our reference angle. However, we have one more step. We have to think of whether sine is positive or negative in the quadrant that the terminal side ends up in. Well, terminal side is in quadrant number 2, and we remember in quadrant 2 sine is positive. So that means the value of sine of 3 pi over 4 is going to be positive. In fact, the sine of 3 pi over 4 is equal to positive sine of pi over 4, or square root of 2 over 2. Let's do another example. Again, we're going to still follow the same rules, and we're going to now look at tangent of negative pi over 2. We're going to find the reference angle. And I'm saying this is always acute. Well, I think I'm going to contradict myself here, because if we look at negative pi over 2, remember, a negative degree rotates in the clockwise direction. That actually lands us right on the negative y-axis. So this reference angle actually is equal to pi over 2. So this isn't really an acute angle. And in fact, 90 degrees wasn't one of those angles that we memorized. Instead, we have to go back to remembering our unit circle. If the point formed by the terminal side where it crosses this unit circle, that point is equal to 0, negative 1. And if we remember that tangent is equal to the y value divided by the x value, well, in this case, y is equal to negative 1 and x is equal to 0. So the tangent of 3 pi over 2 is going to be negative 1 divided by 0, or, well, we're not allowed to divide by 0, so the tangent of 3 pi over 2 is undefined. And that third step, determining the sign, whether the function is positive or negative, well, it really doesn't matter, because if tangent is undefined, we don't have negative undefined, we just call it undefined. So the value of tangent of negative pi over 2 is undefined. Here's one that behaves a little bit better. Cosine of 43 pi over 6. Again, we're going to find the reference angle, but like we did with degrees, we want this value to be between 0 and, well, instead of 0 and 360 degrees, we want this value to be between 0 and 2 pi. So what we'll do is we'll take out complete rotations from this 43 pi over 6 until we get a value between 0 and 2 pi. So after I take out one rotation, well, 2 pi is a complete rotation, but let's rewrite that as 12 pi over 6 so I can subtract my fractions. And that works out to be 31 pi over 6. Well, 31 pi over 6 is still more than a complete rotation. It's still more than 2 pi, so I'll subtract out another complete rotation, and I'll get now 19 pi over 6. I'm almost there. If I take 19 pi over 6 and subtract again a complete rotation, then I end up with 7 pi over 6. And we could go ahead and find the reference angle. Or, if you do what I tell you, and memorize your unit circle, and at the beginning of each exam, take 5 minutes to sketch out your unit circle, then when I get to a question like this, like cosine of 43 pi over 6, once I get my angle down to 7 pi over 6, all I have to do is look at my unit circle, find 7 pi over 6, and then think of, let's see, I wanted to find my cosine. Cosine is equal to the x term. Remember, sine was y and cosine is x. So the value I'm interested in is negative square root of 3 over 2. So once I have my angle between 0 and 2 pi in one fell swoop, I can say that the cosine of 43 pi over 6 is equal to negative square root of 3 over 2. You don't have to memorize that unit circle, but it certainly makes your test much easier to do. If you spend 5 minutes at the beginning of the exam to sketch out that unit circle, then you'll find the rest of the exam much faster because you won't have to rethink about each reference angle because it'll already be on your unit circle. Alright, well there's one last thing we need to worry about in terms of radians, and that's finding approximate values of trig functions. For instance, what's the approximate value to 4 decimal places of sine of 3 pi over 4, tangent of negative pi over 2, and cosine of 1.5? That one's a little bit different. Let's take care of the sine first. Alright, I've just cleared my calculator, but first, let's go ahead and hit mode. Again, we had to be very careful in the first half of the class to always make sure that our calculator was in degree mode. Well, now we're talking radians, so now I need to make sure that my calculator is in radian mode, and it is. Now to get out of there, I just hit second and quit, and now I wanted to find sine of 3 pi over 4. I'm going to use the buttons the same way I did before. I'll hit the sine button, then I'll say 3 pi. Again, I'll hit second and this caret, and above that is my pi symbol, divided by 4, and enter. And I see that the approximate value of 3 pi over 4 is 0.7071. And that should be familiar to you because the sine of 3 pi over 4 we found to be square root of 2 over 2 exactly, and when you approximate square root of 2 divided by 2, that is equal to 0.7071. Well, now let's look at this tangent. We found by hand that tangent of negative pi over 2 was equal, well, it was undefined. Let's see what happens when we use our calculator. Again, I'm going to always check. Yes, I'm in radian mode. And now I'm going to enter tangent of negative. Again, we're going to use this negative button, not the subtraction button. Negative pi divided by 2. And when I hit enter, it says there's an error in the domain, and that's a good sign that we are dealing with a number that is undefined. Alright, what about this cosine of 1.5? This is something I guarantee I will have some students make a mistake on the exam. If I say cosine of 1.5 and you do not see a degree symbol, that means I'm talking radians. Radians do not have to have that value of pi in there. Cosine of 1.5 means 1.5 radians. So let's go to my calculator and let's see what happens. Let's see, I'm going to check. Yes, I'm in radian mode. Cosine of 1.5. That's equal to 0.0707. What would happen though if instead of in radian mode, I used my calculator in degree mode? Then cosine of 1.5 is equal to 0.9997. Because 1.5 degrees, it's very, very close to 0, and cosine of 0 is equal to 1. But 1.5 radians is going to be actually closer to 90 degrees than it would be to 0 degrees. So the mode your calculator in will be the big difference between getting a question correct and getting a question incorrect. No degree symbol, it means radians. And again, cosine of 1.5 is 0.0707, But 1.5 degrees, the cosine of that, was actually a number very close to 1. One final comment, and I'm not going to demonstrate anything, but keep in mind when you're using those inverse trig functions we talked about before, you have to make sure you pay attention to the mode your calculator is in. If your calculator is in radian mode, then the answer you receive will have an answer given in radians. If your calculator is in degree mode, however, that angle that the inverse trig functions give you will be given in terms of degrees. So watch your mode so you can understand what information the calculator is giving you when you're finding inverse trig functions.